Here we are, welcome to my work solutions for the AQA higher paper. As you can see, we're going for the November 2024 series and we're kicking off with paper 1, so put your calculators away. For number 1, if you're lucky enough to know that 15 squared is 225 off the bat, then you've picked up your first mark. But if you didn't know that straight away, it's up to you to work out 15 times 15 using your preferred method. All are valid, but not forgetting there's a missing decimal point. There are 2 digits after the decimal point in the question. You need 2 in the answer, and that's what bags you mark number 2. 2A, we've got number machines going on, always keeping one eye on bid mass. So what have we done to get this y equals 4x plus 5? The x has first of all been multiplied by 4 before finally adding a 5 on the end. Now here, the trebling has been done right at the end, so everything coming out of the first box, that's everything, has been trebled. So I'm afraid it's not a minus 24. It needs to be, you need to take the x and subtract 8. X minus 8 is what happens first, which is why it gets the brackets before it's getting trebled, and that's where the minus 24 comes from. For this number machine, I'd keep it simple. It's times by 6. You want to get back to original, so divide it by 6. But if you want to, you could have times it by 1 over 6. Both are acceptable. Both pick up the marks. What the mark scheme specifically can't have is at the end, coming out of that box, you have 6x. What you can't do to get back to the original is subtract 5x. The mark scheme specifically rejects that possibility. Number 3, firstly, you may know this straight away, in which case good luck to you and get them ticked. If you don't know, pick a little list. There's my small list. The mode of my list is 3. If they all went up by 10, 13, 13 and 14, that means the mode has indeed increased by 10, as has the median. What hasn't, though, is the range. The range at the moment is 1, and if we've increased them all by 10, the range is still 1. The range is unchanged. And as has happened quite recently on the 2023 papers as well, just because there's 3 boxes and there's 3 questions doesn't mean it's 1 box per column. There's not automatically, it does sometimes happen, but there's not automatically one of each answer. On to 4A. Geometric, as you can see, we've got a multiplier going on each time. You could either do 16 times 4 or 256 divided by 4. Either way, it's only worth 1 mark, and that's for the answer. Next, we've got Fibonacci. For Fibonacci, you add these 2 numbers to get the next number. 5 added to negative 9 means 5 take away 9. In goes minus 4. And to get your next number, these 2 now must be added together. Minus 9, which is so debt of 9, added to a debt of 4, takes you down to a debt of 13. 1 mark for each. Next, we have a solid prism. How many faces? There's a hexagonal face at the front and a hexagonal face at the back. It actually doesn't tell you it's a hexagon, because that might be giving you too much of a clue that there are 1, 2, 3, 4, 5, 6 faces as you trace it around. 6 flat, 1 at the front, 2 at second at the back, 8 in total. 5B, the prism has, they're telling you the volume, they're telling you the length, the area of the cross section. Normally, you would do cross section multiplied by length to get volume. So this is working backwards. Volume divided by length to give us the cross section. Any method of dividing picks up the mark. You might be able to do it in your head to get 175 for your second mark. You might need to bus stop it, chunk it, use whatever method you prefer, as long as you get 175 as your end result. Number 6, it's the non-calc paper, so you know you're going to be asked to do a fractions question. The only question is which of the 4 operations, so do make sure when you're revising, you revise all 4, the downside being you know only one of them's guaranteed, but normally you see another one in a wordy question at some point, so it will pay off twice. Anyway, turn it top heavy first. 1 times 5 is 5. Add on the numerator, we get 6. You keep the bottom the same until you're ready to change. You need to pick the lowest common multiple of these. You could do 20 or 50, but 10 is the best. 10 is the lowest, and you only have to change one of them. Left-hand fraction, doubling the bottom, also means doubling the top. By picking the lowest common multiple, you're more likely to have one that doesn't cancel down. So here we go, 12 take away 3 is 9 over 10, and yet it does not cancel down. Number 7, a little bit wordy, but don't be afraid of them. The radius of the large circle is 12. To go from radius of large to radius of small, we are dividing by 4. So the radius of the small is 3. You bag your first mark. We can now crack on. To find the area of the shaded, it's big circle minus small circle. Big circle is pi times the radius squared. Small circle, pi times the radius squared. You get your next mark. The mark scheme says 1 mark for either of those, 1 mark for working out either of those, as in 144 pi and 9 pi. It wants in terms of pi, means pi is in your answer, and you work out 144 minus 9, and you're getting 135 pi for your 4 marks total. Number 8, we are assuming every person works at the same rate. 10 people do the job 9 hours, get them multiplied. That means 90 hours required in total. If we've got 15 people working on the same job, we need to do 90 divided by 15. You may be able to do mental arithmetic to get 6. You may want to try and just write out your 15 times table. You still get 6. You might just want to do it as a fraction. Cancel down, divide top and bottom by 3. What we're getting 30 over 5, which also gets you 6. However you get to 6. 1 mark for method, 1 mark for the final answer. Answer only, by the way, if you've worked it out in your head. Still worth 2 marks, but just risky, because if it's wrong, you lose everything. 8b. In fact, 6 are slower, 9 are faster. What does it mean? Well, here's the problem. How slow is slow? How fast is fast? These 9 people could be the absolute world-leading experts, be literally the fastest people completing this task in the world. These 6 might be quite good, just a little bit below average, in which case it would definitely speed up the job. But these 9 might only be a bit faster, and these 6 might be so bad, they are the worst in the world. So we just haven't got a clue. It is not possible to say in any circumstance, unless you know more details about exactly how fast or how slow people work. Here we've got vectors for number 9. What you need to know about adding and subtracting vectors is you can just scan across the top corresponding elements of vectors. So the top vector is the left and right vector. So the horizontal movement added to the horizontal movement equals the overall horizontal movement. There we go. A has to be 4. Same along the bottom. The vertical movement and the other vertical movement must equal the total vertical movement. We've set up an equation. You can get it solved. 3b is 18. 1b must equal 6. But yeah, they're not bad. Vectors, not as bad as the pictorial ones where you get shapes. Don't skip them. They're not that bad. Number 10. Clive's got 2 coffee shops. It's a Venn diagrams question, you can tell that, but it's also got some number work going on. 1 line at a time. All 4 numbers must add up to 150. You have to come back to that, you can't do anything straight away. But 18 people use both shops. You'll get a mark for the 18 being both coffee shops. 46% use shop A. This is why it's given you working out. We need to work out 46% means out of 100, of 150, of means times. That's what we're working out. Let's divide top by 10, bottom by 10. Let's divide top by 5 and bottom by 5. Let's keep going. Let's divide top by 2 and bottom by 2. We're getting 69 over 1. In other words, 69. 69 people use shop A. That means 51 must go into there. 2/5 use shop B only. Well, 1/5 means divide by 5. 150, we can do a bit of mental arithmetic here. If we divide by 5, we get 30. We want 2/5, not 1/5. 2/5 means we double it. 60 people, in they go. You're up to 3 marks. We want the final bit. That means you've got to do a bit of basic arithmetic, add up the 3 numbers you know so far, and subtract them from 150. You should end up 21, and you've got your 4 marks. Long-winded, well worth spending 5 or 6 minutes on them. On we go. For number 11, I've not cut and pasted it across as I normally do. At the end of the day, you grab your compass. I haven't got one. I'm going to just draw it freehand. You need to get your compasses. They look a bit like that. Metal point, pencil. You need to make the distance 4 centimeters. Get the metal bit on here and draw yourself just over a semicircle. Pick it up, metal point on there, just over a semicircle. You then grab your ruler because you can match them up, hopefully. That should be level, obviously, but mine's bound to be pants. But you're going to end up with basically what looks like a bit of a cylinder falling over, or whatever you want to think about it at the end of the day. It's straight line, semicircle, straight line, semicircle, and everything is 4, 4, 4, 4. No matter which part of the line you are stood on, you are 4 centimeters away from the line that's been given. Boom! And as if by magic, that is what it should look like on your page when done properly. On we go. Come on, there we go. Right, we are converting a fraction into a recurring decimal. Keep it simple, don't overcomplicate. If you try and learn shortcuts, it'll just not work out. This is really saying 27 divided by 11. For me, there's no better way of doing a divide than sticking to bus stop. It's given you a clue that it's recurring, so I would go with 3 decimal places, lining up my decimal points and crack on with short multiplication. 11 into 27, goes twice. Count up, count on, your remainder is 5. So we know the answer is 2 point something, but on we go to find the recurring bit. We're looking for where it starts to repeat. 11s into 50, 4 11s are 44, we'll have a remainder of 6. 5 11s are 55, we'll have a remainder of 5. And there we go. If you want to carry on for another step or so, feel free. We actually know the answer. But just to wrap it up, here's what happens. 11s into 50, 4 11s, remainder 6. It's going to go 4 5 4 5 forever. You need a dot above the 4 or the 5. And I'll just mention while I'm here, an alternative is to put a line over the recurring part. That's just as correct. 12b, going in the other direction. Whenever you are asked to convert a recurring decimal, get on with the process of x equals, times it by 10, 100 and 1,000 if that's the way you've been taught. And obviously if you've practiced it quite a bit, you might realise you don't need both 10, you don't need all 3. But let's do all 3 to show ourselves why. Move them all up 1, so it becomes 1.5 recurring. Move them all up again, 15.5 recurring, and move them all up again, 155. Now, why does your teacher tell you to do 10, 100,000? It's because they're asking you to look, where does the recurring part repeat straight after the decimal point? So we actually, as you can see, we didn't need to go to 1,000, because at the point where we reach 100x, we have 0.5 recurring and 0.5 recurring. We could have just stopped right there, done bottom, take away top, 100x, take away 10x, 15.5 recurring minus 1.5 recurring. The recurrings cancel. You're really doing 15, take away 1. And you're at the final stage of solving it. Divide both sides by 90. You can simplify it to 7 over 45. Doesn't ask you to, so why bother? 13a, we've got a good old sort of estimating, but we're asked to use each one to one significant figure. So before you do any estimating, do the one significant figure part, because you're bound to be picking up marks for that. 401, show the examiner one significant figure is 400. Show the examiner that 1.9 is 2. Don't jump straight to 8. Show the examiner that 58.7 is 60. Now you can start working things out. The root of 400 is 20. 2 cubed, 2 times 2 times 2 is 8. And cos of 60 is the same as sine of 30, which is a half, which I'll write as 0.5. So the numerator part, we get 28. And don't forget, when you divide by a half, it's the same as multiplying by 2. But as I say, don't just jump to that straight away. You must show your working. Show them that you do the one significant figure part first. Number 13b, one of them long-winded ones. Now, I've always written these out properly and in full on my model answers. Not going to do it here, I'll just highlight what's gone wrong. Now, actually, in Sam's working out, they've done 3 mistakes, and you just need to point out any 2 of them. So the first thing is, as you may be able to see, 3 squared plus 7 squared is not 10 squared. That's the first one I'd put. And how do you say that? Well, work it out. At the end of the day, it's 9 plus 49. Work it out. Sometimes the best way of showing how someone has done something incorrectly is by doing it correctly. Next, what else has Sam done wrong? They've got a plus. It should be minus 2bc cos x, and so on. So we've got incorrect use of BIDMAS here because they've added before they've worked out indices, but they've also got a negative. Third mistake is another bit of BIDMAS really. As you can see, what they've done is they've done 10 squared is 100 and added that to 42. Absolute no. They should be getting the 5 squared to be 25, subtracting 100 from both sides before dividing by 42. As you can tell, the third thing they've done wrong is quite a long-winded thing they've done wrong, so probably best off sticking with the first 2 I mentioned. But as always, only worth 1 mark each. Don't feel the need to write out 6 or even more lines. Nope, short and sweet, get straight to the point. Speaking of points, vertices. Always treat enlargements and a few other sort of transformations. It's just counting. It's posh dot to dot. You're told the centre is 0, 0. To have a scale factor of negative 1/3, that really means divide everything by 3, and if you divide everything by a minus or multiply by a minus, doesn't matter, it changes sign. And what does that do in coordinates? Right becomes left, up becomes down, and so on. Let's pick vertex P. From the centre, that is up 9 squares. Divide it by 3 and reverse. We go down by 3. That's where the image of P will be. You don't need to label it. Let's count for Q. That's 9 right, 9 up. Divide everything by 3 and reverse it. We go left 3, down 3, in it goes. Finally, vertex R is right 9, up 3. Divide everything by 3 and reverse it. You end up with going left 3 and down 1. And I'll grab my quote-unquote ruler. I'll join them up reasonably badly. Well, I'm not doing too bad. It'll do the job. We'll live with that. But there we go. And that's it. And you lose a mark for each mistake you make, by the way. If you, for example, if it's a square out, lose a mark. If it's the wrong size, lose a mark, and so on. If it's the wrong way up, lose a mark. And if you're the sort of person who uses the raise method, I don't. I use the raise, get your see-through ruler, and line them up. It's a nice way of double checking. I don't think it's a nice way when essentially the best method is counting. You can use the raise, as you can see there, as a way of making sure you haven't miscounted. Make sure that the original, the centre, and the new vertex all line up. Number 15, we are solving an inequality. Treat it like an equal sign. There's a couple of ways of doing this. You can either get rid of the minus right at the start by adding it to both sides, or you can do it at the end. But don't forget, when you times or divide by a negative, all inequalities must flip around. You must deal with that. But I'll get rid of it straight away. I'm going to add 5x to both sides, whilst subtracting 30 from both sides. And I'll now divide both sides by 5. And that's a perfectly reasonable answer. Examiners will accept that. If you've done it the other way or you want to reverse it, as long as the x has the open side of the inequality, the greater than side, they're both correct. Both are going to score all 3 marks. 15b, represent x is greater than -1. Firstly, you must have a circle above, on, or below -1, and you must have greater than. I would prefer it personally if you take your arrow right to the end. The mark scheme's not that fussed as long as your intention is clear, so an arrow there is fine. On to 16. It's errors and bounds, but actually it's something more specific called truncation. Truncation's a bit like if you had a number written down on a piece of paper, like that, and the piece of paper got ripped. What sort of is the lowest? So truncation is the lesser used version of errors and bounds. We don't use it that much. Normally, you go up and down by half the rounding amount, not for truncation. For example, what's the lowest? If we didn't know that, what's the lowest this number can be? Well, it's a load of noughts. It could be 8.51. It couldn't actually go any lower because the 1 is still printed on the piece of paper. It's still written there. So truncation is a form of errors and bounds, but it is to be treated much, much differently. Sasha writes the error interval as that. Give a reason why Sasha is wrong. The reason you need is that the smallest, if it's truncated to 8, the 8 can't be a 7. The 8, the smallest it can be, is 8. That is literally the smallest number that Sasha could have had. So that should be on your lower limit. And for your upper limit, mark scheme allows either 8.9 recurring, because it could be 0.9 forever. An easier way of writing 8.9 recurring is 9. And the mark scheme's a little bit generous. It does accept 8.9 as well without the recurring sign. A little bit generous that, but never mind. They're on your side. There's your 2 marks. 17a. A circle has a centre and a circumference. So work out the equation of the circle. Firstly, you've got to think about, well, what does the equation of a circle look like? That requires the revision of, it's x squared plus y squared equals, and the final bit, which I'll leave blank for now, would normally be the radius squared. There's your question, there's your logic. Work it backwards. What is the radius? Well, we know the circumference, and we know that the circumference is equal to 2 times pi times the radius. The pi's cancel. If we divide both sides by 2, we get that r equals 18. And if you wanted to work out 18 squared as being 324, that's acceptable as well, but why bother? It's only worth 2 marks. You're getting 1 for the radius and 1 for the full equation. Don't bother working out 18 squared. It's not worth your time. 17b. Work out the equation of the straight line. Whenever you're asked for equations of straight lines, good news, We know coordinates. Bad news, we don't know the gradient. There's your first job. The gradient of the line from J to K, change in Y's over change in X's. So I'm going to do 0 minus -5, because change means difference, which means subtract. Keeping the order the same, 15 take away 30. So the numerator gives me 5, denominator minus 15. You don't have to simplify it, but obviously it's easy enough. There's no perpendicular going on, so we don't have to flip it or any rubbish like that. You've got the gradient. You now need the equation of the straight line. And as you may remember, that means it needs to be in that form. We already know that the gradient, is -1/3. We need the plus c. How do you get the plus c? Pick one of the coordinates along with the gradient, sub them in. Sub them into y equals mx plus c, and you can find where it crosses the y-axis. So there's the formula. Let's replace y with 0. Let's replace m with -1/3. X with the x coordinate of 15. And the c is what we don't know. 1/3 times 15 is 5, so that works out to be -5. Hey presto, add 5 to both sides. That's your value for C. Plonk it on the end, and you've got your 4 marks. Next, number 18. Pretty obvious what it's asking. Don't forget, if you need to revise it, it's called completing the square, and the method is quite simple, particularly when there's nothing special about it, when there's no coefficient of x squared, when there's no odd coefficient of x. You can just get on with this. Halve the number next to x, it's 4. Squaring 4 gives 16. You need to take it away and simplify it with the -5. You get 1 mark for the x plus 4 part and 1 mark for the -21 part. 18b, I'm scrolling down so I can use the blank at the bottom for a bit of illustration. Don't forget that when you've got a curve, the minimum point, also known as the vertex, is also known as the turning point. It's the point where the gradient turns from being a negative to a positive, or vice versa. Write down the coordinates. The coordinates of the turning point, which we, as I say, we know as the vertex, is in this case, with it being a positive x squared, it has a minimum value. The minimum value of these brackets is 0, because when you square it, it can't be any smaller than 0. And that can only happen when the x minus 7, they cancel out. So 7 take away 7 means that disappears. And what are we left with? 8. Now, I'm sure some teachers will have told you the shortcut, which is absolutely fine. Change the sign of the x, keep the sign of the y. I'm not against that. It's fine by me. Number 19, we are expanding a cubic. You are free to pick any 2 brackets and expand them first. I just go with the first 2. X times 2x, 2 times 3. You'll notice I don't do it in quite the correct order because I like to speed things up. Now I do the x terms mentally. 2 times 2x is 4x. That's 3x. 4x and 3x gives me 7x. Loops. I don't like loops when you're taking it forward to bring in the 3rd bracket. because it means 6 loops. And trust me, 6 loops means a whole lot of stuff can go wrong. So we need to multiply the top row by 3 and x. 6x cubed, 21x squared, and 6 3s are 18x. We now multiply the top row by 4. 8x squared, 28x, 24. It now needs to be simplified fully. The cubic term is quite happy. The numerical, the constant term is also, it's the others that need simplifying. You've got 21 and 8 of the same thing, everything's positive. We have 29, 18 and 28. That means we have 46 of them. And there we go. Now, they're linking in part B. Use your answer. Hopefully you're spotting that 102 is, as you can see it, 100 plus 2. In other words, they are saying to you, by saying this phrase here, they are saying x is 100. So if you can substitute x equals 100 into these, you'll be able to add up all the answers and it'll save you from doing that multiplication. So 6 times x cubed, that's 6 lots of 100 cubed. That's 100 times 100 times 100. You've basically got 6 zeros. We now have 29 lots of 100 squared. Try and line it up. That'll be 4 zeros with a 29 at the front. Then we have 46 times 100. That'll be 2 zeros with a 46 in front. And we've got a 24. And you'll notice it's a very easy sum to add up because there's never anything in the same columns. You know, there's never anything adding up to more than 10. So no need to carry anything across. You can simply scan the digits as you see them. 6,294,624. Take a deep breath, because you're done. We're now into surds territory. It's a non-calc paper. They're always going to happen. The key to part A is spotting that 363 is a multiple of 121, which in its own right is a square number. So we can split the 363 into 121 times 3, and there you go. The root 3's cancel, and you know what the square root of 121 is. It's 11. Part B, to rationalise, we multiply top and bottom by the bottom. And we perform it as if it's a fractions question. Top times top, bottom times bottom, root 5 times root 5 is root 25. In other words, 5. And we do need to simplify. 20 divided by 5 gives us 4. And there we go. Number 21. Bit of a weird one. Most people, I'm sure, are always expecting sine and cos. Unfortunately, here we go. We've got a tan. For part A, think of, you could have drawn that line on if you wanted to. That's absolutely fine. Because what happens on the tan curve? The tan curve repeats every 180 degrees. So when you know one solution, you add 180 to get your next solution. We add 180 to 78 0.69. And as you can see, it'll end up with a 0.69 on the end. We just need to add those two together. Do it however you want, on your fingers if you want. It's 258.69. Now the next bit, work out the two values of x, where tan x is -5. Now this requires the knowledge that you can see that the tan curve has rotational symmetry. What I mean by that, the bit you're trying to spot is that this line crosses there, which if you could rotate 180 around that coordinate here, that's where it would end up. So the idea of that is, firstly, wanted that. This first solution, however, it is up 5. This solution is down 5. This solution is a certain amount below 90, or you could think of it as above 0. This solution will be the same distance either above 90, if your teacher tells you to use 90 as your line, then you need to be adding on to 90, but your teacher might be telling you to subtract from 180. As I say, because the idea is from 0 to 78.69, that's the same distance from 180 down to this coordinate. What's all that waffle mean? It means to get your first answer, you've got to do 180 minus 78.69, which is probably easier by doing it as an add-on, because the difference between 80 is quite close to 78. It's basically 1.31. But there we go. I will see I've done that quite quickly. I'll do another video on solutions to these at a later time. But yeah, it is to do with the rotational symmetry aspect. Basically, whatever up becomes down, whatever left becomes right. But as you know from part A, when you've got one solution, you just need to add 180 to get the next solution. 281.31 degrees. For number 22, we're matching some boxes, but don't rely on luck. The idea is it's ultimately a laws of indices question. You've got a bit of, so 7 to the n equals x. You've got a little bit of room downstairs. Whoops. If we're told that 7 to the n equals x, then what does this mean? This means we've got 7 to the power of n all squared, because power to a power does indeed mean multiply the powers, as in 2n. Now if you replace 7 to the n with x, it's x squared. In it goes. This next one, the powers have been added, which means another way of writing 7 to the power of n plus 1 is, well, if they've been added, it's a multiply. 7 to the power of n times 7 to the power of 1. We're applying laws of indices in reverse. Well, 7 to the power of 1 is 7. 7 to the n is x. And that's all we're interested in. The fact is, it's just 7x. There we go. So next one's like a 50-50, but ultimately it's very similar to this one. 7 to the power of a half times n is 7 to the power of n all to the power of a half. What does power of a half mean? It means square root. So ultimately, we end up with the square root of x. Let's try to catch you out with the half x. Nope, we're not falling for that. Number 23. We've got the equation of the graph y equals x squared, and it's been moved up 2. That's what's happened. Y equals x squared is the same graph doing that. It's been moved up 2 units. If you've been revising your transformations of graphs, hopefully you'll remember that if you want to move a graph up 2, you simply stick a +2 on the end. That's it. Move it down 2, that'd be a -2. If you want to move it left and right, that's where the x becomes things like that. But that's not what's happened here. So not today. And finally, B and C. What's happened here is a graph's been reflected in the x-axis. It's been flipped upside down. What that really means is, as I hope you may know with every graph that looks like that, they are graphs of the form y equals -x squared. And that's it. The entire graph has been multiplied by -1. That's what's flipped it upside down. And part C is what I was saying towards the end of part A. This graph has been moved to the right 3 units. So the 3 is going in with the x in the squared part, not on the end, but horizontally is the opposite way round to what you always expect. To move something right 3, despite being in the positive direction, it should be a -3. And there we go. So that's my walkthrough for that paper. Hopefully that's helped a lot. Let's crack on. I'm now going to go on with the calculator paper. Hopefully see you there. Ta-da.